Let's talk today about a new concept. Well, it's not new, it's new to us. We're basically starting in the Hibbler text, we're starting into chapter 6. I think it calls it probably something like structural analysis. Structural analysis. This is basically trusses, frames, and machines. I like a good old-fashioned Oxford comma myself. Trusses, frames, and machines. We're going to start out talking about, as I mentioned right at the beginning, something new to us. It's an old concept, the idea of a truss. If I could write a U, that would be helpful. T-R-U-S-S, truss, or the plural trusses. A truss is a structure of slender members joined together at their endpoints. They are typically attached with bolts. That's nuts and bolts. So you got a beyond kind of our course here, but you typically have a bolt being something, some might call it a screw. Okay, it's basically something that has a threaded end, and you would have a nut, and there would be some washers and things like that, but you'd have this nut would then thread down on here. You would have members of some kind that would be maybe 2 or 3 of them stacked in here. Going in multiple directions. So I'm looking at the end, so to speak, of them. So multiple pieces in here sandwiched together, and you put a screw on this and you screw it all the way down and sandwich them together, and you would join them all together. So typically attached with this is the idea of a bolt, and this would be a nut that I would use to fasten, to tighten down the bolt, so to speak, to hold them all together, hold these pieces all together. Might be attached with bolts, or what we call a gusset plate. So a gusset plate would be, where I might have, if I have what we would normally draw as a pin. This would be an example of, so something where these members would be attached at a common point. They'd all be additional stuff out here. I'm just drawing this rough edge to indicate that these continue going on in those directions. And this would essentially be, if they were connected with a bolt, it would look like this, or pin. If I have a gusset plate, I might have basically kind of a small little plate, and it would have a member would come in like this maybe, and another member would come in like this. If you've ever looked in the attic of a house or something like that, and you look at the big wooden structures that hold up the roof, it's called a truss. That's your roof trusses, and you might see something like this at the end, and these things would have either nails driven through them or these might have some rough surface that you can hammer on. And basically these plates, this is essentially a gusset plate. These plates would basically attach these members together somehow. So either, again, if I'm looking, this is a very terrible drawing of the looking from the side of this. And again, I'm basically seeing the bolt here, and behind you would have a nut, and you would tighten these down to sandwich all these things together. We're only going to see them in 2D. We're going to see them all kind of flat, but in realistic, they're all going to be stacked kind of slightly off and behind each other. And again, with the gusset plate, probably some kind of nail or some other kind of attachment is actually biting into each of these members and holding them to a common plate. Now, for us, in this class, we will treat all truss endpoints as pins. And so just like in chapter 5, we'll treat them as pins where there are then forces with a direction at each endpoint of each member. So we're going to assume that they're all pins, even though realistically they're either a bolt that's been screwed down tight or some sort of a gusset plate attachment, and that's what we normally see out in the wild, if you will, in the real world. Okay, so some things happen when I'm dealing with a truss. If I'm dealing with a truss, we'll talk about frames and machines later on in chapter 6. Initially in chapter 6, we're going to talk about trusses. And what's the big difference? Well, the biggest difference with trusses versus a frame or machine is that with a truss, loads are applied to the endpoints of the members. I'm going to pause it here, make sure I'm using the right microphone. I don't know why I told you why I'm pausing. I could have just stopped talking and paused it, checked it, and came back. Anyway, here we are. Assumptions. We're going to load all of the members up only at the endpoints. And again, all joints will be smooth pins. Even if it's a gusset plate, we're going to treat this as if it's all these members are joined at a single pin connecting all three of them. And that's what we're saying here. And so whether it's bolts, gusset plates, whatever they are, what I mean by this is we're going to treat both of these as if it's just this. And so some sort of pin connection holding all of the slender members together. All loads along each of the members are only applied at the endpoints. That's some sort of external applied load at this endpoint, or some sort of reaction at this endpoint, or whether it's just simply the forces in each of the members themselves. All loads pass to endpoints. And so what happens there, these assumptions cause every member in the structure to be a two-force member. All right, now there's quite a bit to unpack there. Let's see if see how we do. Let's unpack this just a bit. We need to start a second page. 11 is going to be page 2 of something. Okay, so each member is going to be a two-force member. Let's just look at a truss or something like a truss here. Okay, I'll show you what I'm going to draw. So I'm going to draw something like this. Right, so kind of a triangular structure with a bunch of overlapping members. What do we mean here? So it doesn't have to be exactly like that, but, and you kind of get used to drawing overlapping where the endpoints just kind of barely overlap. I should go grab something from the lab or print something up to kind of demonstrate this. Something like this. And so we're going to have points, pins, connecting each of these. And let's say I apply a force F1 here, and we apply a force F2 there, and we apply a force F3 there. If this is how we set this up, loads are applied at the endpoints of the members. So these are the two assumptions we're making. If I'm going to treat something like a truss, I've applied forces only at the endpoints of members, and I'm going to treat each of these pins as if they're smooth pins. If I do that, what happens then is if I look at each of the members individually. So if I only, let's say this is point A, B, C, and D. So if I look at then only member A, B. So I'm only drawing a free body diagram of A, B there. Well, basically what I've got then is if I'm applying these forces up here at the pins themselves, then that means when I only draw this guy, really all I've got is I've got the pin right here at A. I've got A at some unknown angle theta. And I've got a pin here at B, some unknown angle phi. So if this is what we're looking at, if you remember in chapter 5, we talked about this concept of two-force members, which means that if I've got something where an object where there's only two forces acting on it, the only way that two forces can cause equilibrium on an object to where it's not moving and it's not rotating is for those forces to be equal and opposite, collinear. Because if they're not collinear, we have a moment being caused here. So the only way this is going to exist in equilibrium is if I've got these two forces pushing or these two forces pulling. But those are the only two ways these are the only two options to achieve equilibrium with only two forces. So go back and make sure you understand in chapter 5 the concept of two-force members, because that, just like everything else, that shows up here. And it's kind of one of those things we talked briefly about. So this is a thing. You'll see those here and there, and here it is. We're seeing it again. This is the concept of two-force members. The only way a two-force member, an object that only has two forces acting on it, can be in equilibrium if those two forces are equal and opposite and collinear. And so what happens is, in the case of a truss, if all the forces are only applied at the endpoints, these are the assumptions, loads are only applied at the endpoints of the members, joints are all considered to be smooth joints, there's no couple moments caused by frictions in here, then each one of these members, if I take any one of them out, this is the only way that any one of these members can exist in equilibrium, is they're going to be in one of these two configurations. And that's a nice stopping place we'll pick up on the next video.